All right, so this is regarding problem number 8 in your WebAssign practice for lesson 5-3. So this is just a little addendum. So in that problem, you're being asked to find the derivative of the function capital F prime, where f is defined something like this. So this isn't the same problem, but it's similar. So notice this time around, unlike your other FTC Part 2 questions, neither of your limits are a constant. And remember, in order to use the fundamental theorem of calculus Part 2, one of those limits needs to be a constant, preferably the lower one, but we can always switch it if it's not. But in this case, both of them are functions. And so in order to approach this, we actually need to think back to Unit 4 when we had some of our properties of integrals. You might recall that one of our integral properties said, if I have the integral from a to b of some function, plus the integral from b to c of the same function, that equals the integral from a to c of that function. But remember, this property works both directions. So if I have a single integral, I can break it apart by using that same approach. And that's exactly what we're going to do here. We can break apart this definite integral into the sum of two other integrals where the shared limit is the constant. And it doesn't matter what constant we use. That's the nice thing about it. So I could randomly say that this is the same as the integral from x to 0. Again, I'm just choosing 0 randomly. I could have chosen 1. I could have chosen pi. I could have chosen any constant. I'm just going to use any constant I want. So we're going from x to 0 of t squared dt plus the integral from 0 to x plus 4 of t squared dt. So the reason we do that is, so now to find f prime, remember that I'm just finding the derivative with respect to x of that sum. Oops. That's from x to 0 of t squared dt plus the integral from 0 to x plus 4 of t squared dt. And then now, because this is a derivative of a sum, remember that you can take the derivative of each term separately. And so what this now becomes is just two smaller FTC Part 2 questions that are similar to the ones that you have seen. This first one, notice that the limits, one of them is an x and one of them is a constant, but the constant is in the wrong place. So this is similar to the example where you would want to flip. So again, remember, this is the same then as the derivative with respect to x of the opposite of the integral from 0 to x, t squared dt, plus, and then for the second one, we don't have to switch anything, but remember that since our upper limit isn't just an x, it's an x plus 4, that we do have to use the chain rule when we actually evaluate that derivative. So now when I apply the fundamental theorem of calculus Part 2, the derivative of negative integral from 0 to x of t squared dt, that becomes negative x squared. Plus, and then for the second part, again, remember the t gets replaced with the x plus 4. So I have x plus 4 quantity squared times the derivative of x plus 4 because of the chain rule. But the derivative of x plus 4 is just 1. So I have negative x squared plus the quantity x plus 4 quantity squared. Again, it's times 1, so that's just going to go away. And then we can simplify that just a little bit by expanding. So I get negative x squared plus 8x plus 16. Those x squares do cancel out in this particular example, and this just ends up simplifying to 8x plus 16. Okay, so that's how you can approach a problem like number 8.